Pure Mathematics 3, A Levels 9709. We are going to study complex numbers today. When any number p, say, is squared, the result is either positive or 0. That is, p square is greater than or equal to 0. Such numbers are called real numbers. If I say to solve x square plus 1 equals 0, you will get the result something like this. X equals square root of negative 1. The root is clearly not real. We call it an imaginary number. So square root of negative 1 is named iota. In short, we write it as small I. I equals square root of negative 1. Imaginary numbers can be added to and subtracted from other imaginary numbers. For example, 2i plus 5i gives us 7i. The product or quotient of two imaginary numbers is real. For example, 2i times 5i will give us 10i squared, which is minus 10. Why minus 10? Since I equals square root of negative 1, so squaring the both sides will give us I square equals minus 1. So place minus 1 in I square, so you get minus 10. Also, 6i divided by 3i will give us 2. Power of I can be simplified. Like I cube can be written as I square times I, which is negative I. Because I square is equal to minus 1, so minus 1 into I is minus I. I power 4 can be simplified by writing I square whole square. This gives us negative 1 square, and the final answer is 1. I power 5 can be written as I power 4 times I, and the result of I power 4 already you have seen as 1. So write 1 in I power 4, 1 into I is I. I power minus 1. So to convert the negative index into positive, I have to reciprocate it. So I am going to write 1 over I power 1 or just I. Now rational the denominator, or you can say rationalize the denominator. How to rationalize it? Multiply and divide by I. So you get I over I square. Again I square is minus 1, so your final answer is minus I. When a real number and an imaginary number are added or subtracted, the expression so formed, which cannot be simplified, is called a complex number. For example, 2 plus 3i, 4 minus 7i, minus 1 plus 4i, all are the examples of complex numbers. A general complex number can be written in the form a plus bi or x plus yi, where a and b can have any real value including 0. Operations on complex numbers. Addition and subtraction. Real terms and imaginary terms are compounded in two separate groups. For example, 2 plus 3i plus 4 minus I. So we are going to add 2 with 4 and 3i with minus I. So write 2 plus 4 plus 3i minus I. Now solve it, you get 6 plus 2i. Another example is 4 minus 2i minus 3 plus 5i. So subtract 3 from 4 and 2i and 5i will be subtracted by writing 2i plus 5i. So 4 minus 3 is 1 and 2i plus 5i is 7i. Multiplication. The distributive law of multiplication applied to two complex numbers gives their product. For example, 2 plus 3i times 4 minus I. So 2 will be multiplied by 4 and minus I, and then 3i will be multiplied by 4 and minus I. So you get this. So finally, we get 11 plus 10i. Another example is 2 plus 3i times 2 minus 3i. We are using negative 1 in place of I square. Note that the product here is a real number. This is because of the special form of the given complex numbers 2 plus minus 3i. Any pair of complex numbers of the form a plus bi have a product which is real. Such complex numbers are said to be conjugate, and each is the conjugate of the other. Thus, 4 plus 5i and 4 minus 5i are conjugate complex numbers, and 4 plus 5i is the conjugate of 4 minus 5i. If a plus bi is denoted by z equals a plus bi, then its conjugate a minus bi is denoted by z star. Division. For example, if I write 2 plus 9i divided by 5 minus 2i, note direct division by a complex number cannot be carried out, so we have to rationalize the denominator as we did in the previous example. So multiply and divide by the opposite sign of 5 minus 2i. So it becomes 5 plus 2i divided by 5 plus 2i. So numerators will be multiplied by each other and the denominator will be multiplied by each other. The zero complex number, a complex number is zero if and only if the real term and the imaginary term each are zero. Equal complex numbers, suppose a plus bi equals c plus di, a plus bi minus c plus di equals 0. Now collect the real parts and the imaginary parts. So a minus c minus b minus di. So a minus c equals 0, b minus d equals 0. So a equals c and b equals d. Thus two complex numbers are equal if and only if the real terms and the imaginary terms are separately equal.